Imagine holding the source of genius in your hands, the very organ that rewrote the laws of physics. This is the true story of Albert Einstein's brain. After his death, Einstein's brain began a journey of its own, promising to reveal the secrets behind his intellect. We'll explore what scientists discovered when they examined the mind that gave us ELMC2, a mind that bent space and time. Einstein wanted no shrines or displays. He requested a simple cremation, his ashes scattered in secret. But fate intervened. One decision in an autopsy room set off a saga that would last decades, raising questions about the link between brain structure and genius. Was Einstein's mind physically different, or was it the way his brain was wired? The quest to understand his brilliance took his brain from a New Jersey hospital to labs across North America. This isn't just a story about a famous brain. It's about our fascination with the mind's potential. As we uncover the discoveries made from Einstein's brain, consider, what truly makes a mind brilliant? The greatest wonder may lie within the 3-pound universe inside our skulls. The journey of Einstein's brain after his death is as strange as any of his thought experiments. On April 18, 1955, Einstein died at Princeton Hospital. During the autopsy, Dr. Thomas Harvey removed the brain, without the family's permission, hoping to unlock the secrets of genius. Einstein's son was furious, but Harvey convinced him the brain would be used for science. Thus began a bizarre odyssey. The brain, floating in formaldehyde, traveled with Harvey from New Jersey to Kansas and back, sometimes stored in a cider box under a beer cooler. For decades, the scientific community waited for results, but little was published. The world's most famous brain had vanished from public view, becoming a legend. Only in the 1980s did Harvey begin collaborating with modern researchers. He had photographed the brain, then sectioned it into 240 blocks, creating over 1,000 microscope slides. Photographed the brain, sectioned it into 240 blocks, created over 1,000 microscope slides. Finally, the wandering relic was ready to reveal its secrets. The first real data in the quest to understand genius was about to emerge. The story of Einstein's brain became a tale of lost opportunity, scientific obsession, and eventual revelation. Lost opportunity, scientific obsession, eventual revelation. It's a reminder that the pursuit of knowledge can take unexpected and sometimes controversial paths. The brain's journey was as extraordinary as the mind it once housed. Now, science was ready to look inside. To understand Einstein's brain, we must meet Dr. Thomas Harvey, the man who took it. Harvey was a competent but little-known pathologist, not a famous neuroscientist. His decision to remove the brain was driven by a sense of scientific duty, not fame. This choice cost him dearly. He lost his job, faced personal turmoil, but never gave up his role as guardian of the brain. Harvey meticulously preserved the brain, photographing it and cutting it into 240 blocks, each embedded in celloidin for thin slicing. He created thousands of microscope slides, sending samples to researchers, but never producing a comprehensive study. For years, the scientific community remained in the dark. Only when Harvey partnered with neuroscientists at UC Berkeley and McMaster University did real investigation begin. Harvey provided the material. Modern teams brought new techniques. Decades after that fateful autopsy, the world finally began to learn what made Einstein's brain unique. The first findings about Einstein's brain weren't about its cells, but its size and shape. Harvey found the brain weighed about 1,230 grams, slightly less than average for a man his age. This challenged the idea that bigger brains mean greater intelligence. The answer had to lie elsewhere, perhaps in organization or connectivity. The brain was in excellent condition for a 76-year-old, showing few signs of aging. This suggested exceptional neural resilience, possibly supporting Einstein's clarity and creativity late in life. Harvey's photographs revealed something unusual. The Sylvian fissure, a major groove, was shorter and differently oriented than normal. This could have allowed greater connectivity between regions linked to spatial reasoning and math. The first clues pointed to a unique brain architecture, not just size. These observations set the stage for deeper microscopic analysis. The puzzle of Einstein's genius was beginning to take shape. The secret seemed to be in the brain's design and wiring. The next discoveries came from looking at Einstein's brain tissue under the microscope. In the 1980s, Dr. Marion Diamond at UC Berkeley received tissue samples from Harvey. Diamond studied glial cells. support cells once thought to be mere glue for neurons. She compared the ratio of glial cells to neurons in Einstein's brain with other men's brains, focusing on areas linked to higher thinking. In the left parietal lobe, crucial for math and spatial reasoning, Einstein had a significantly higher ratio of glial cells. This suggested his neurons had higher metabolic needs, working harder, supported by more glia. The finding was groundbreaking. Perhaps genius lies in the support system, not just the neurons. Critics noted the small sample size and imperfect controls, but Diamond's work shifted focus to the partnership between neurons and glia. The study opened a new frontier in understanding intelligence. Genius might be found in how brain cells collaborate, not just in their number. The brain's support network could be as important as its main processors. Einstein's cellular architecture was unlike any seen before. One area of Einstein's brain drew special attention: the parietal lobes. These regions are key for spatial reasoning, visual imagery, and math, the very skills that defined Einstein. In 1999, Dr. Sandra Whitelson's team compared Einstein's parietal lobes to those of other men. They found his parietal lobes were about 15% wider than average, providing more space for neural circuits involved in abstract thinking. Another striking feature, a groove called the parietal operculum, was largely absent, possibly allowing more extensive connections. This could have created a more integrated processing center, enhancing his ability to synthesize information. Einstein's brain wasn't just wider, it may have been better connected. These findings suggest his brain was physically optimized for the kind of thinking that revolutionized physics. While we can't prove these features caused his genius, the evidence is compelling. The shape of his mind seemed to echo the shape of his thoughts. The parietal lobes may have been the seat of his extraordinary abilities. Research into Einstein's glial cells continued, focusing on astrocytes, star-shaped cells that support neurons and help regulate brain activity. A 2013 study examined Einstein's prefrontal cortex, linked to planning and abstract thought. The astrocytes there had more complex branches, suggesting they could influence a larger neural territory. This complexity could mean more efficient processing and better integration of information. It fits the image of Einstein lost in deep thought for hours or days. The combination of more glia in his parietal lobe and more complex astrocytes in his prefrontal cortex points to a brain that was exceptionally well supported. These support cells may have provided the foundation for his sustained intellectual effort. The housekeeping cells of his brain acted more like master engineers. The secret of his genius may have been in the vast, intricate network supporting his neurons. Einstein's brain was a model of biological efficiency. Despite these discoveries, debate rages. Do these features explain Einstein's genius? The biggest challenge is that we have only one Einstein, no way to know if these traits are unique or common among other brilliant minds. There's also the question of nature versus nurture. Was Einstein born with these features, or did his brain change through a lifetime of intense thought? The brain is plastic, capable of changing in response to experience. Some findings, like the missing parietal operculum, may be rare but not unique. Control groups in early studies weren't always ideal, making conclusions tricky. Science is a process of refinement, and the story of Einstein's brain shows how initial ideas are tested and challenged. No single genius button has been found. Einstein's brilliance likely came from a rare mix of brain structure, lifelong learning, and the right moment in history. The brain was the instrument, but he was the musician. The journey into Einstein's brain leaves us with more wonder than certainty. We've found clues: a brain of average size but exceptional health, uniquely shaped parietal lobes, and a richer network of glial cells. Each finding hints at a physical architecture suited for abstract visual thinking. Yet, the full picture of his genius remains elusive. These discoveries pushed neuroscience to look beyond brain size, focusing on organization and efficiency. Genius is not a single thing to be found in one fold of the brain. It's a symphony of biology, environment, and relentless curiosity. Einstein's brain may have given him a head start, but it was his passion and persistence that changed the world. Preserved in museums, his brain remains a source of fascination and humility. The ultimate secret of genius may not be on a microscope slide, but in the spirit of inquiry that drives us to keep exploring. The mystery of Einstein's mind endures, inspiring us to ask new questions about our own.